So now, without further delay, I'd like to turn it over to your first presenter today, and that is Danny Kita, Product Manager with Intergraph. Danny, you have the floor.
Good morning and welcome to everyone, and thank you for joining us today. Just a quick review on the topics we'll be covering today. We'll spend a little time talking about the ongoing immersion in all things 3D that we're experiencing because I think that makes a real definitive statement about the future of geospatial software. Then we'll spend some time talking about creating a 3D representation in GeoMedia 3D with a particular focus on using existing data sets. Having said that, I'll warn you that this won't have all the charisma and excitement of a Hollywood blockbuster movie in 3D, but it is the practical starting point for geospatial in regards to the third dimension. And then we'll show you how 3D can dramatically improve geospatial analysis by the addition of a 3D context. In case you're wondering, the picture on this slide is from the Flat Earth Society. It is still very active today, and I sincerely hope that none of you are contemplating joining. So let's get started. As you're likely aware, the general population is becoming immersed in 3D. That's no surprise, certainly, because that is our natural habitat and how we experience the world. As consumers, we've been exposed to video games, movies, and television in 3D already. And then if you add to that 3D-enabled personal computers, 3D printers, along with cell phones, and GPS devices that show 3D landmarks now hitting the market, I think the consumer technology is moving very rapidly to 3D. And if you're wondering about the pace that it's moving, the picture on the right is of a 3D printer. And many of you may have heard about these amazing devices, which use printing methodology to render a 3D result or deliverable. I can send you a link to a YouTube video. If you haven't actually seen one of these in operation, just send me an email after this webinar. But what's most amazing about this is that the 3D printer in the picture off to the right, the mechanical components on it are made from Legos. Moving on, the pace is also picking up for 3D model building as companies who create content professionally, consumers who create content for their own purposes or as a hobby, along with government organizations and industry are starting to consider the future and how to also participate in the evolving trend towards 3D. Now, for the geospatial community, this means accelerating 3D activity from just stereo data collection and terrain modeling onto 3D representation and analysis. 3D is becoming an expectation for all of our daily experiences, and it's not going to be confined to just our leisure time. At Intergraph, we've 3D-enabled the GeoMedia desktop with the technology extension to provide a seamless integration of the classical 2D top-down view with the new 3D environment. This extension enables our users to leverage their existing data sets and their GeoMedia tools to create 3D representations of their data, and they can also incorporate 3D models into the mix. And when done, you still have access to the analytical capabilities of GeoMedia. .3D applies to all the market sectors that Intergraph serves, whether it's a government organization looking to gain public approval for a highly complex technical project, or a transportation department wanting to evaluate road safety or changing conditions, or a utility or communication company visualizing underground infrastructure to an intelligence group performing a situational analysis, or public safety and security user who's visualizing a destination to brief first responders on what they're about to encounter when they arrive on the scene. 3D provides a real context that creates a high tide of value to raise all boats in all markets that deploy it. So moving on to GeoMedia 3D, GeoMedia 3D will process all standard imagery that GeoMedia currently works with, and it will do this against the backdrop of the globe because, yes, the world is not flat. And as you add elevation from digital elevation models, DTED files, GeoTIFF, SDTS, or ERDAS Imagine files, to name a few, the imagery will automatically drape over that surface. Based on the data that you have, you'll make a determination on the level of detail that it can support, and then in turn decide on how you want to represent that data in the 3D map window. And this is done on a feature class by feature class basis. Extruding, for example, if you have height information, or categorizing and adding textures if you have the ability to access more detail, and if there's a strong desire to more realistically depict that feature. I'm going to show you what I mean by this in a little bit, but let me first talk about 3D models and how GeoMedia 3D handles them. GeoMedia 3D includes a utility to import 3D models. It creates a footprint and a pointer to the model, so users can easily add 3D originated data to their data mix. The import utility currently supports CityGML and Google file formats, and we do have plans in the future to add additional standard formats. So I'll give you a brief walkthrough of what I've been talking about. What we're seeing here is a number of feature classes, and I'm just going to show you a couple, but I think that'll give you the flavor for how this will work. And I've got one that I've called buildings to extrude, so I just simply have height information for those buildings, so I'm going to do a simple extrusion. And then I've got some residential, commercial, recreational feature classes, as well as some hospitals and fire stations. So what I've done with the residential, because I have some more definitive detail, I've done some GeoMedia queries, and I've broken it up into small, medium, and large based on the number of floors that I have in that building. So, you know, obviously the high rises, anything above 10 floors or so will be large. Anything between 3 and 10 will be a medium, and less than that would be a small. And I did that for the purpose if I wanted to assign different textures to them, I could. And I didn't actually do that here, but just wanted to give you a flavor for that. So let's look at the buildings to extrude. I'm looking at my standard GeoMedia dialog, and when you load GeoMedia 3D, what it does is it adds a new tab to the properties dialog called 3D settings. And if we look at the 3D settings tab, it gives us some options on how we want to place our objects in relation to the surface, and then also whether we want to extrude or texture them. You'll note that I've done a little best practice here that although I'm using my max height attribute to extrude the building, instead of just placing it on the surface, because I am in a hilly area, I've offset my building minus 10 meters, and then I've added 10 to the height. So I'm still maintaining my height accuracy, but I'm getting it to sink into the earth so I can account for any hilly terrain to get a nice fit for the building with the terrain. So I have access to all of the numerical attributes. As I mentioned, I'm just going to use the max height attribute here. And then the fill in GeoMedia properties will determine what the color will be for my roof. And then the boundary will set what the walls will be. And I can select from the GeoMedia color palette for that. So let's look at the small residential. In this case, I have a texture I want to put on to the building. So I'm going to extrude it by the building height. And then I'm going to point at a texture. And what I did, I just took some simple textures to give you an idea of how this would work. These are all clip art that I downloaded. So I've got some window textures for residential, some bricks I can use for commercial, some columns for my recreational, and then some stripes. And I found some chili peppers as well. So in this case, I'm using the windows. I put them on the residential features. And I'm going to use the same texture for the medium and the large, although I could have selected some different textures. The recreational is going to get the columns. I'll use my bricks for commercial. The hospitals will get the stripes, and I decided I would use the chili peppers for my fire station. So also the 3D models, I brought them in through the import utility, and just to show you how easy this can be added to the mix, I'm going to tell it to replace with a 3D object. The 3D object is GM 3D model. That attribute was created by the import utility, and the values in that field for that attribute will essentially be a pointer to where the model is stored. So I just simply need to come to this tab, assign that feature class to this newly created attribute, and all the models will then be put in position. So let's take a look at what that's going to do to my 3D view once I leave these settings, and then we'll navigate down and have a look at what all those feature class settings will do to my actual features here. So along the coastline, you'll notice there's some 3D models. These were Google files that I imported. They're put into position. The models are pointed to. You can notice that I've got the residential buildings with the windows in the background. I see some gold-roofed commercial buildings. As we navigate around and I go east, there's a park, so I see the recreational buildings with the columns on it with the green roof. Let's go find the hospital. There it is off in the distance. I can see the bright red and white stripes easily. You can also notice that I have my extruded buildings with the dark roofs in the general vicinity. We'll do a fly around. So what's left? I need to find the fire station. So let's see, I think there's one off in the distance. Yeah, there it is. So if I circle around and navigate in a little bit closer, you'll see that I have my chili pepper texture on the fire station. And again, this is just a sample. I use some simple clip art here. You can get as sophisticated or complex as you need to, but any type of texture can be applied, and the significance is just so you can readily determine what you need to in your landscape. So once we've set up our feature classes, if we want to go another step forward in terms of creating a realistic setting, we can look at street furniture. So if we want to, we can assign 3D models to point features. You can use available attribution to affect the representation or determine which symbol you want to use using attribute-based symbology. So let me show you a little bit about that. So what I'm going to do here is I've got a couple point feature classes. I've got some trees, fire hydrants, I have some street lamps. We'll look at the tree feature class, and same thing, go to my 3D settings tab. What I've done in this case is I have some attribution. I use the expression builder to assign symbol based on what the attribution tells me. It could be a clean palm or a pine or an oak tree. And I also use an expression for scale because I have some growth status information about the tree. So I'm going to close off the legend and we'll navigate down and have a look. So you can see there's a palm tree to our left. I've got some trees decorating the avenue. There's an oak tree. I've got some pine trees. We'll take a closer look at some of the pine trees. Take a look at the properties. You'll see I have growth status and type attributes, so I'm going to use those for my expressions. In this case, the type for this tree is a 2, making it a pine, so we'll change it, and it'll be a palm tree. Also, I'll just undo that, so we put it back to a pine. We can change the growth status. So growth status here will become much more immature and show us a smaller symbol. And then keep in mind that these are done dynamically. So my GeoMedia connection to the database, as the data would change, this would dynamically refresh. And then we'll just take a quick look at the fire hydrant. I have some pressure information. So if I wanted to graphically depict what the pressure would be like, let's say, across the downtown area, I can go in and use that pressure to extrude. And then what I'll do is I'll just exaggerate it times 2, just so we can see it for the purpose of this demo. And then it updates and extrudes my fire hydrants based on that pressure reading. So we'll take a look at this one. We'll change it back to a 1, and you'll see that it adjusts dynamically for that. Okay, so that was a real quick overview of things you would do to set up your 3D representations on a feature class by feature class basis with GeoMedia 3D. I think the best way to really show you the value of 3D is to take you through an application scenario. We have a number of them prepared to discuss with you today. And with them, we hope to provoke some thoughts on how 3D can be used to add value to your geospatial operations. So the first one is a signal intelligence scenario. The background to this scenario is that we have a person of interest who has been transmitting messages that have caused security concerns. It's been called to the attention of authorities that such that they're looking to make a positive identification and a possible apprehension. So from a geospatial perspective, the considerations are that we've identified 3 potential locations where these messages are being sent from. We've done a signature analysis to determine where the hotspot for the origination of the message might be for any particular time of day. We've done a viewshed analysis using another extension to GeoMedia Desktop, GeoMedia Grid, and with that viewshed analysis, we'll establish observation locations based on the analysis. And we'll use that to decide where the best placement of observers and apprehension teams would be. And then we'll use 3D to perform a walkthrough of the scenario to familiarize with what it actually looks like. So we'll go through that briefly. You'll notice this is familiar to the top-down view of geospatial software. You'll see that I have 3 identifications denoted by the 3 red point features. As it turns out, using 2D for this part of the exercise provides the advantage that because I want to use to scale symbols in 3D, if I were to do this now in 3D, it might not be as obvious. Of course, I could make my observers 30 feet tall, but the objective here is to try to get them as true to the environment as possible so I can have a sense of what the scenario would look like. So I'm going to use the 2D view to decide on placement, and then I'll move over to 3D to do my walkthrough. So with that, again, the 3 locations, 2 are in a business district. I've got 1 near the beach. The hotspot analysis has determined that it's location 2 where we want to do our analysis. So we've used GeoMedia Grid, performed the viewshed analysis. I'm just going to show the results of that on the screen, and you can see we have rims of visibility from being completely visible to partial visibility. And then we'll use that to place 3 observers. We'll put 1 with full visual sight out in front. We'll put 1 as a secondary observer and a 3rd one in the back alley. And then we'll have 4 apprehension teams, 2 covering the front exits and 2 covering the back alley. So now I'm going to go over to 3D, and we'll have a look around what that scenario looks like. You'll see the viewshed. I'm going to navigate around and get a better look at what things look like on the ground. You'll notice I put a little red light overhead, and I've floated that in the air so I can find my locations very easily in the 3D view. As we navigate down, I've got my rings of visibility. If I back up a little, I'll find my first observer, and there he is. He's in full view of the building that we want to put under observation. I'm going to shut the viewshed off, obstructing the view a little bit. And we'll get rid of the legend so we can see the full screen. There's one of the apprehension teams over on the left. If we go forward and to the right, we should see our secondary observer and the second capture team. So we'll navigate around in 3D, and there they are. There's the secondary observer and our capture team. So now let's go and try to find the 3rd observer in the alleyway with the other 2 apprehension teams. So this becomes a test of video gaming skills here, and we can get a glimpse that there's one of the capture vehicles we click sight on. And then as we move into the alley, we should see our third observer, and there's his head showing. We'll navigate down a little bit, and now if we look forward, we'll see the fourth capture vehicle. There he is. And so now, reminiscent of an arcade game, we'll take a stroll down the alley and come out in front to the front street. And keep in mind that this is still GeoMedia desktop software. This is GIS software, but now has the look and feel of an arcade game at this point. But gives us a good understanding of what the situation on the ground might be instead of just having to look at it from above. So as we come out to the front street, we're going to see the first observer come into view pretty shortly behind, or not behind, but next to that palm tree. There he is. And then if we look to our left, we'll see our secondary observer again, and our two capture teams if we navigate just a little bit. And then, again, to reemphasize the point that this is geospatial software that we're using, the top-down view that we're familiar with. So at this point, I'd like to introduce Robert Gannon. Robert's the functional designer for GeoMedia 3D. Robert's going to join us and take you through 3 more application scenarios.
Great. Thank you, Danny. That was a really good introduction. And what I hope to do here is just drill down a little bit further and also continue on the integration side between GeoMedia and our add-on products such as GeoMedia 3D. And so Danny asked me to talk about a scenario about a tower placement scenario. And so what we wanted to do here was demonstrate how we could use the products to basically improve on that particular process. So what we're looking for is we're looking for a location where the new tower was going to be within 3 kilometers of the existing tower. The other component was that it had to be in line of sight of the existing tower. And we also wanted to use our GIS here to also take a look at it being zoned as commercial, park, or vacant. And then ultimately, we wanted to put this tower as high as possible in the environment and thus be able to keep the new tower as short as possible and therefore as unobtrusive as possible. And you'll notice that I also say ideally we wanted it to be on relatively flat land. And what we found is after doing the analysis that when we went on flat land that was high, that actually it turned out to be better to go on some land that was higher up but not as flat so that we could keep it actually a little bit shorter. So we're going to do a little demonstration of that, and we're going to go through a scenario for you. And so what you should see on your screen fairly quickly here is we've now gone in GeoMedia. We're in the 2D top-down view, if you will, and you'll see in the sort of middle of that screen this dot there, and that dot currently represents the existing tower. So what I'm going to do is I'm actually going to be turning on some layers and off some layers, really just to give you context to the analysis. I'm not going to be doing the analysis per se as we actually go through this because time wouldn't permit us to do that. But for now, let's go ahead and take a look at the kinds of things that we would need to do this type of analysis. So in this particular case, what I wanted to do is turn on the digital elevation model that we actually had of the area. And if you notice in GeoMedia Grid in this particular case, which we're running, we can actually turn that digital elevation model on, and then we can actually query the data that's in there simply by clicking. So you see that's 1 meter, that's 6 meters, and that's 97 meters. And basically, you can start to see that as we go over towards that terrain area there, Diamond Head, that the value is about 99 or 93 meters above sea level. So that's very nice to be able to do that. And so we're going to use that information to help us find all the areas that are high. The other thing we talked about is we ultimately wanted to put this on relatively flat land. So we can run a command in GeoMedia Grid that allows us to take a look at that surface and then, in essence, report back a rise over run value. And that rise over run value, in this particular case, when we're close to that tower, is a 0. It's flat. And as we started to make our way over to Diamond Head, you'll notice that those values increase, so the rise over run is getting quite steep. Again, just another input. If you remember back to what we were talking about, it was also had to be within the visual distance of the existing one. So what you'll see here is my tower. and then how far we can see out. The dark areas are what we can see, and then the areas that are not affected are what we cannot see. I thought what I would do is just really quickly just throw on a buffer so that you could see the difference. If you were taking into account no elevation at all, what you would be able to see, and you'll notice that, of course, you get a perfect circle in this particular case. So let's go ahead and take a look at this in 3D. I'm in 2D right now. I don't really need any of this stuff on for this particular case. I'm going to turn that off. And let's just zoom into where that tower is. Now, you're going to notice I'm going to turn off the aerial photographs. And why did I turn off the aerial photographs in this particular case? Well, I turned those off because we're actually hitting something called a Intergraph server. And that Intergraph server is actually giving us information over the internet. So all that imagery that you see that just came in there is actually coming via the internet. We also have the ability to create content files that you do not necessarily need the internet to feed data for those who don't have access to the internet. But in this particular case, we actually use the internet as a mechanism to get those aerial photographs. So what we can do is we can just start to use some of the navigation tools here to take a look at the existing tower. So I'm just going to come down a little bit, and we have that existing tower that you can see off there and get an idea of how tall it is in context of everything else. So going back to our original scenario, we wanted to look at all of the areas that were based upon a particular land use. So I can use GeoMedia now to do a query and say, hey, go and find me all of the parcels that meet that particular criteria. So I can go and I can display that on, just like I can display anything on inside of the 3D environment, just like I can in the 2D environment. And what's going to happen is your window is going to update with that information. So you'll start to see, and way off in the distance there, we have a whole bunch of polygons that met that particular criteria. But what I wanted to do is I wanted to actually query one of those so we could look at those. So when I query it, we actually get information about that polygon. If I just make that a little larger, go down here a little bit and take a look, you'll see we have attributes that are important to the analysis. We can actually have attributes associated with which way that parcel is facing, what the average elevation in meters is, what the maximum elevation in meters is, and you'll notice we also have a slope because we wanted relatively flat land. So what I thought I would do is just use GeoMedia to actually bring up and just do a classification of that, just to show you how nice this integration is. Because for those of you that use GeoMedia, you probably do this all the time, where you do a classification. So I've got the classification. I'm just going to apply a color sequence to this. In this particular case, it's going to be at the bottom here. We've got that color sequence, kind of a green through red. I apply that. The system automatically updates, and now what we have is we have those polygons are now being basically colored by that underlying attribute. So you can see the legend is updated to reflect the underlying values, which is slope in this particular case. And of course the colors represent that. Very nice. We can now see that that one is pretty flat. But keeping in mind, we wanted to get this as high as we could. So I said, hey, wait a minute, give me every point or every polygon that is basically high up, but also meets the criteria of the actual parcels themselves. And you'll notice it found a couple here. Now these are flat because I asked for them to be flat, but I've also asked for them to be high. So we can use GeoMedia and GeoMedia Grid in this particular case to actually place that particular new tower at the highest location within those two polygons. And in this particular case, it placed it towards the back. So that was pretty good, but after we did some further analysis, we determined that that thing had to be about 100 feet high in order for it to do what we needed it to do. And we had a mayor living in the area or something like that, and they said, I don't want that tower in my backyard. So we said, hey, you know what? Let's not worry about it having to be flat land now. Let's just go and get me the highest parcel of land that meets that commercial park or vacated land. And you'll notice that one came up right beside it here. So what we can do now is, again, ask the system to place a tower on there at the highest location. And after we did the analysis, we found out that that tower really only had to be about 40 feet high versus the 100 feet high back up in the area. And what I thought I would do is just really quickly throw on a representation of our building footprints that we have. And those come on just as simple blocks in this particular case because we don't have models for this. We could have textured those, as Danny's already shown you, but this really gives you an example of how you can quickly take your footprints and just extrude those very easily and get a good rendition of what we're seeing there. So that gives you a pretty good intro to that, and we'll move on to the next scenario. Now, this particular scenario is something that we've been working on recently, and we've added a lot of LiDAR capabilities to our GeoMedia Grid product. And we're now in a position to process copious amounts of LiDAR data very, very quickly. I'm not going to concentrate on the LiDAR aspect of this, just we've given a couple presentations on the new LiDAR capabilities in Grid. I really wanted to show how those can be used in conjunction with GeoMedia 3D. But the consideration here was that we have airborne LiDAR data available to us. We wanted to do this analysis on a bare earth digital elevation model that actually uses the LiDAR data sources. And ultimately, we wanted to delineate the flood extents and depth, that's the important part, using water levels of 880, 890, and 900 feet above sea level. So in this case, it's actually a Department of Transportation that's doing this work, and they want to know the assets that are at risk based upon this scenario. So we can, of course, do a lot of GIS capabilities. I'm not going to go all into that today, but ultimately what I want to do is show you how we can kind of do that thing and then start to visualize and examine the results in 3D. And then ultimately, I want to be able to share my results with my colleagues. So I'm going to show you how we can actually output to an AVI in this particular case. So if we just continue on, we're going to do a demo here. And I'm going to go ahead and get ready to do that. So what you'll see on the screen here is something that's pretty Spartan. There's not an awful lot of stuff here. But the key component that we wanted to demonstrate here is that how we can use and generate use LiDAR data to generate a digital elevation model, which we can then ultimately do some analysis on, then use that digital elevation model that we created from the LiDAR data as our surface data when we do the 3D visualization. Okay? So without further ado, let's go ahead and take a look at some of this. So what you're seeing on the screen right now is something called LiDAR footprints. And we can do LiDAR footprints. We actually use a command called last files to feature class. And this is actually a fantastic little command that allows you to point to an extremely large collection of last files, and it creates this representation of footprints for you. And we're literally talking about thousands and thousands of footprints and millions of points. So the first step really is to create those footprints. Once we have those footprints, we now have something called a LiDAR workbench, and that LiDAR workbench is what we now use to actually generate our digital elevation models. Now, the important part to understand here is that this new workbench is multi-threading, and as a result, it's extremely fast. It can process many points almost interactively. It's incredibly fast. And we have given demonstrations on this. Again, I'm not going to concentrate super on the LiDAR aspect of it and on this, but I did want to bring it up so that you can see it. And it works on the actual footprints that you create. You can load from footprints, and then you have a number of commands that allow you to basically create a digital elevation model. I can share those models and save those models. But again, I'm not going to concentrate on that. I really want to start to go into some of the analysis and some of the 3D. So what we did is we used the LiDAR workbench to create a digital elevation model here. And of course, you can pop up the footprints just to see how those are matching up. We don't really need that, but I did want to show you that that's where they came from. And of course, I've shown you a little bit before how we can quickly query and get elevation data for that, just so you get an idea of what the elevation in the area is. We can poke around and we can do profiles, a whole bunch of things, but really just wanted to show you that. So the real key here is that we have this dam location, and then that dam location that you see there has been placed on one of the river systems within the environment. So we're actually placing it within that environment, and then we want to see what its effects are in terms of the water that it's going to hold back. All right? So they wanted to do a number of different depths. So the first one they wanted to do was at 900 feet above sea level. So if I display that on, what you're going to see is it's going to give us a representation of this where the color now represents the actual depth of water at that location. So it's as little as 1/2 a foot, point of a foot, right up to as many as 30 feet. So we can verify that simply by clicking. You'll notice that it's giving me here how deep the water is at that specific location. As I move further and further away from the dam, you'll notice that the water shallows until a point where it's actually only about 1.2 feet of actual flooding in that area. So they wanted to run multiple scenarios, so I did that. We did it at 890. And, and we just colored that sort of a light red through a dark red. And, of course, we can verify what it does. So now I'm not looking at just one scenario. I'm actually looking at two. And then, ultimately, we did another one at 880. And we can do it, and it's colored sort of a light green through to a dark green. So we really accomplished the first piece. Now that we have that, we can start to do further analysis as what assets are falling within that kind of stuff. But when you start to do that kind of analysis, what you want to be able to do is you actually want to be able to convert that to vector features so that we can do that kind of thing. So we have a command that allows us to basically go ahead and do that. We can convert from raster to vector very simply, and I did that, and we have the vector representation of the 880 extents in this particular case, and there it is. So let's pop into 3D and just kind of see what's going on. So in this particular case, you'll see that the aerial photographs come in because, again, I'm on the internet, but you'll also see that we have the elevation data coming in. In this particular case, it's just a simple color sequence of a dark gray through to a light gray, and that's been draped on top of that elevation data, okay? But the key component to understand here is that we actually we're using the digital elevation model that we created from the LiDAR workbench as our underlying data source. So you can load a whole bunch into here, and you can turn them on, turn them off, all kinds of things, which is very nice to be able to do. So you can look at post, pre, there's all kinds of analysis, or not analysis, but all kinds of visualizations that you can do here. And this is really just done literally on the fly by doing add surfaces to the using the add surfaces command. So that's important to understand, and you'll notice I'm also using the default internet.fly file in this particular case as my base content file. So what I wanted to show is that the integration is pretty strong, and if you have an add-on product and it uses the 2D window, typically what will happen is you can use it in the 3D window. I'm just querying the elevation data here. Just wanted to show you that that worked. So what I want to do is I actually want to do a profile. We could have done the profile in the 2D window, but it's kind of interesting to do it in the 3D window. So what I'm going to do is just move my way down into the dam area that we have here, pop in behind it, and then I'm going to use the little profile. And you'll notice that when you do that profile, it actually hugs the surface, and I've just kind of gone across that area. And I click when I'm done, and I can simply say, what do you want to do it on? And it gives us a representation of that flood. And you'll notice it's just under 900 feet, going up to about 1,100 feet. So we can copy that data to the clipboard if we want to, or we can actually copy the chart itself to the clipboard. Very nice. So we can, of course, use all the abilities to get around here, but I don't really want that digital elevation model, in this case, the representation of it, so I can turn it off. And once I turn it off, we now get the extents of the flood in the 3D environment. Perfect. But I really want to go ahead and start to take a look at this, but I want to use some of the commands to do this, and we have the ability to do flight paths inside of GeoMedia 3D. We can create a new one, we can edit existing ones, and we can, of course, fly a flight path that exists. So in this particular case, I already created one, so we're going to go ahead and we're going to fly it. So you'll notice that when I do that, we get a nice new little guy up here, basically allows us to move around. The other thing is you're seeing select set there. What we can do is if we had a road or something like that, or multiple vertices making up a road, I could certainly select that road, and I could fly along that road if I wanted to, or I could even persist that as a flight path. So in this particular case, I'm not going to do that. I'm actually going to go ahead and use the flight over flood scenario, and it shows me what it looks like in 3D. I see it sitting there, and we can just start to play it, and it's going to go ahead and fly right through that environment. There's all kinds of things you can do here. If I pause it, you'll notice it came up for us. We can go forward, go backwards, those kinds of things. We can loop. The other thing is we can actually step outside of the aircraft and go to the side if you wanted to follow a road from the side, that kind of thing. So in this particular case, I'm done. I just wanted to go ahead and stop it, and I'm just going to zoom way out just so you can get an idea. But we can also record the flight paths, and this is if I wanted to be able to save this and give it to somebody. So you'll notice I can select any flight path that I have, and then I can output it. And the output right now is an AVI file. In this case, I'm putting it out to my G drive, and I can do it at 30 frames a second down to as little as 10 frames a second. I find that 15 works really well. We can compress the video if you want, and we can actually do the current size, which is the actual window itself, or choose a predefined one such as 480 or 720 if we wanted to. So I'm not going to do that here because it's really just kind of boring at that point, but it does create an AVI. And you'll notice as we zoom out, I just wanted to give you an idea. We were in Ohio in that particular case, and I'm just zooming out to a world view so you get an idea. Perfect. So we have one more we'd like to show you, and this is not necessarily a scenario per se. It's kind of a feature, but it is something that I think you'd really want to see. So in this particular case, what we decided to do is show some of the features of the product. And that feature is this ability to actually go below ground, and not only go below ground, but be able to visualize inside of buildings as well. So we want to view that structure that is both above and below the ground. And you'll see here in this first one right here is we're actually got an opacity setting. You can see that there's a building below the ground, and those darker areas are the ones that are above ground. And then we can actually go below the surface and view that structure from outside that surface. And you'll see there I got a little check mark just to show you that. And then ultimately what we can do is we can penetrate that and actually go right inside of this particular subway station that we have. So with that, let's go take a look at what this might actually look like. So I'm just going to go ahead and get this set up. So what you'll see on your screen here is a fairly straightforward one. We've got some aerial photographs. We've got a couple buildings, wetlands, and you'll notice something called subway stations, and that's actually a point feature because in this particular case I downloaded a model, and we used this model of a subway, and we put it into the environment, and you'll notice right away that you can only see really 4 portions of that subway. You've got one sitting right here. You've got one sitting over here, and this is really access to the subway. These are the pieces that are above the ground in this particular case. Now, this is funky. This is great. So it allows us to do subterranean traversal. So when we turn that on, we can now go below the ground. You'll also notice some flight defaults. You can preset those so that when you fly. Now, I'm just going to stop right here just for a second, and what you're going to notice is you're going to notice that the aerial photographs have kind of lightened up a little bit. In this particular case, that means that I can now see through those, and we can now see how those actual stations are connected. So we see this building that's actually lurking underneath the surface itself. So let's go ahead and I'm just going to actually fly a flight path because I have a nice flight path that I want to do, and I can't remember. I think it's, let's go ahead and do underground 2, yeah. So in this particular case, there's my flight path, and I'm simply just going to go ahead and play that guy out. So we have all these options, which we kind of went through before. I talked about going forward, going backwards. We can reverse and actually go backwards itself. We've added a loop to it as well, but let's go ahead and take a look at this, and you'll notice that. Now, it's going to look a little jerky, but this is because we've actually had to record the screen to do this. You won't see that as much. But as I'm coming down, I'm about to hit the actual surface, and then once ultimately I hit the surface, you're going to see my view change. I'm just tilting it off a little bit, going off to the side. We're going to come down here, and boom. We actually are now below the surface, and how can I tell I'm below the surface? I can see that black grid line that's there, and now all of a sudden where we were seeing the building that was kind of grayed out, well, now it's in perfect view. And of course, we can now traverse even underground. So I'm starting to make my way underground here, make my way into this actual subway. And once we hit the side here, we're now in the subway, which is very nice. So we can get a visualization of actually what's going on in that particular subway. And Danny always makes this joke about the movie Ghost. Just for those movie goers that have seen Ghost, remember when Patrick Swayze jumps through the actual train itself? Well, in this particular case, that model is not just the exterior, but the model itself actually includes the interior of that particular train car. So as we start to make our way, we're going to actually hit that train car, and we're going to go inside it, just like in Ghost. And we'll take a look and visualize it out. And then we'll start to make our way above the surface. and you can see where we go and what is above and what is below ground. So that's just, you know, some really kind of interesting and very nice functionality that we've added to GeoMedia 3D. And we could sit here for probably days and show you all kinds of stuff, but we were only given an hour. So at this point, I'm going to turn it back to Danny to close us out.
All right, thank you, Robert. That was some really cool stuff that you showed, and how GeoMedia 3D can lend value to a number of scenarios. The visual communication aspect of 3D, as you've seen, extends beyond the workstation through the use of fly-throughs. GeoMedia 3D gives you the ability to capture, to review, to make adjustments, record it as a video when you're done, and then you can distribute it to your stakeholders for their review. So to summarize what we've talked about today, GeoMedia 3D solves the problem that classic top-down views of geospatial data make it very challenging to perform an analysis and come to a decision, especially if you need to do that quickly. 3D enabling the GeoMedia desktop provides a more realistic understanding of your data, leading to quicker, more confident decisions. You can perform the appropriate analysis more proficiently while gaining the ability to more effectively communicate the results of that analysis to a non-technical audience. One final note, our future plans are, we certainly intend to propagate the 3D technology that you've seen today throughout the Intergraph Geospatial product line. And I trust that today's brief walkthrough through the application scenarios has communicated to you the value of 3D in your professional life, and also why we like to say it's not just visualization, it's the power of GeoMedia, now in 3D. That concludes today's presentation, but before we open it up to questions, we do have a couple questions that we'd like to ask of you first. So the first question, what is your GeoMedia 3D status? If you would please answer, I believe you just click on the slide in front of you. Already working with 3D, evaluating options. It's in our short-term plans, it's in our long-term plans, or if you currently have no plans. So I'll just allow a little bit of time for those of you out there to respond, and we appreciate your feedback. Okay, we'll just give it a little bit more. It looks like entries have stopped, so thank you very much. And the second question is, what standard 3D file formats do you envision you will be working with? And choices are CityGML, Google, which is KML or KNZ, Galata, SketchUp. And if your answer is other, if you'd be so kind as to send the question to the presenter, you can tell us what that format would be. We're certainly interested in understanding what are the formats that you see as important to you as users. So I'll allow some time for responses. Okay, it looks like we're topping off. Again, thank you very much. We certainly appreciate the feedback that you've provided. And if you do have some questions, you can submit them, as explained in the intro to this session, on the Q&A tab, and then I will give it some time. I think we have a couple in the queue. We'll start to go through those. So, Robert, if you want to join me.
Yeah, I'm here. I definitely see questions coming in.
Okay, yeah, this is a long one, so...
Deal with Danny. Danny, we're going to do that, right? So we've got some questions coming in, so let's go ahead and we'll start with these. And we'll get as many as we can get done here, but there's quite a few coming in. But we will definitely respond to all of these, just so you know. So one of the questions is, during the session, 3D extrusions and models were already applied to the preloaded into the map window. Can any general statement be made or additional from scratch demo be performed regarding the performance and speed of GeoMedia 3D in creating these visualizations? And then there was a note that the follow-up of the fire hydrants demo partially answered this question. So the key understanding is here that no, you don't have to pre-do anything really in the 2D window and then toggle to 3D. What you did see was we were using the 3D styles, which is an extension to the GeoMedia styles. So even when you're actually in 3D, you can start to modify those styles right from within the 3D environment itself, simply by clicking on the legend and then bringing that up and then modifying the styles accordingly. And you did see that in the case of the fire hydrants. But the key thing about the fire hydrants is that not only were the styles being changed, but remember that you're connected to your GIS data. So if your GIS data is changing behind the scenes or in the back end, that those modifications or those changes in the database will be percolated right through to the 3D environment itself. Okay? Danny, I'll let you handle this one. It's can you publish to a 3D PDF? Because I know you were doing some work in this area.
Yeah, currently the GeoMedia 3D software is to allow you to bring in multiple sources and visualize them. In a future release, we will be providing export capabilities, so that will be sometime in the 2012 timeframe.
Okay, and it says here, so this is just the results. So besides CityGML, Google, and also AutoCAD. Okay, so these are some additional models that.
Oh yeah, that was just a response back from the question. So.
Yeah. Okay. We see that currently using pictometry data. So we can actually use pictometry in the 2D window. We have the ability to be able to point and click. And with that point and click, what will happen is, of course, your pictometry data will come up in a separate window. That's something we recently added to GeoMedia. And the reality is if you're in 3D, you should be able to, excuse me, still do similar to that point and click environment. And then it will actually track where you point and click, and it will ultimately bring up that pictometry data that makes the most sense for that particular location.
Yeah, that actually was added with GeoMedia 6.1.10 release, and so we just inherit that as an extension, but it'll be able to synchronize with the pictometry view.
Okay.
Okay, another question. Can I design 3D models in GeoMedia 3D? I guess I'll take that one. We don't envision that you would want to spend a lot of time on a geospatial platform designing the models. So our philosophy is essentially design the models external, and we'll focus on importing the formats and then being able to utilize them in the geospatial environment and do the analysis on those models once they're brought in.
Danny, if you could handle the one too. There's one here about, do I have to set up the 3D representation of feature classes for each project?
Oh, okay. Yes, I will. For your master database, right, what we were showing in terms of the decisions you would make on how you want to represent a feature class, once you've done that, you can save that out to a library. So then the start of any new project would begin with the first step of importing your library, which would have all those feature class settings, so you really wouldn't have to do it more than once. Of course, if you were bringing in some new external data set and it didn't conform to the attribute conventions, then you'd probably have a little bit of work to set up some new things or find, equivalent attributes that would accomplish the same thing.
Okay, and I think we're running out of time, but we've got one more here. What version of GeoMedia is required for the GeoMedia 3D add-on? And it's 060101, just so people are aware. And I think we're right at our time, and I know we have a hard stop. So if we didn't get to all of your questions, we will certainly email you those answers. But for now, I think, Danny, if you want to just sign us off, I think we're good to go.
Okay. Well, first, let me thank everybody for attending today. We know your time is valuable, and we appreciate you spending some of it with us. Before we wish you a good day, though, we would like to take you to one more place, and this is a drop-off point for the GeoMedia 3D. It's the link that was showing on the previous slide, so www.intergraph.com/GeoMedia3D. So if you care to browse for some more information or watch some more videos or just, gather some more information, you can click on the links on your screen. They're enabled, and so you can, spend some more time to explore the world of GeoMedia 3D. So in closing, again, thank you very much for your attendance. We appreciate you spending the time with us. And let me just say that the world's not flat, but why view it that way? Thank you very much.